Hey, all my wood turning friends. I frequently get asked about tool design and grinding. Grinding a gouge is one of the most difficult things to learn as a wood turner. And once you finally do learn the concept of sharpening a gouge, you can sharpen just about anything. So when I'm out and about teaching, the question usually is how fine of a grit wheel are you using on your grinder? And I think people are surprised by my answer. And it's because I come from a wood turner's perspective as compared to another discipline in woodworking, like a wood carver who might opt for a very sharp tool. Well, if you think about this, if I'm spinning a bowl at 1,000 RPMs and it's 12 inches in diameter, my gouge is seeing over a mile of wood in under 2 minutes. So that's a tremendous amount of wood. So if I use a super sharp edge on my gouge, it's going to be torn away really quick. So maybe I'm not looking for the pinnacle of sharpness. Let's talk about that. So we have these names for gouges: fingernails, Irish, Ellsworth grinds. They're all hybrids of each other. And gouges haven't been around a long time, 125 years, and I think they were developed in Northern England. I'm going to challenge you to go into your shop and look at your gouge just the way I have it viewed here. And notice what I've got here. I've got a lot of tool steel here on the side of the gouge. And that's because I'm hand sharpening. If you're working with a jig, you're probably super grinding the sides because the jig can't manipulate the tool like the hand. And it grinds most of this steel off. And that's a problem because now, let's just say you have a 45-degree bevel on the nose of your tool, your sides are more like 20. And now the tool is going to self-feed unevenly. It's kind of a grabby tool, hard to control. Also, notice I have a relatively sharp arc on the top of my tool. And I do this because of control. When you hit the gouge on the spinning object, if that gouge has a long front on it, it skates a little bit until you get bevel contact. Now let's look at the side of the gouge here. A lot is made about the angle of our bevels, and rightfully so. It is important. And I know I hear people say 40-40 is the best, and I don't particularly hold true to that. But again, this is my gouge. Look at this angle here. I'm going to call that a 45-degree angle. And that means I'm measuring off of the interior flute there. That's our datum. You can also measure from the top here. And so half of that is 45 degrees. And that's an easy concept to understand. But if I said 40 degrees, it could mean 5 degrees sharper this way or 5 degrees more obtuse that way. You have to come to an agreement as to where we're measuring the gouge from. I think 45 degrees is perfectly fine for most North American timbers. Now, why do I say that? Because this angle here that we're talking about is determining the density of the timber. So if I was working with pine, a very soft timber, I might even go more acute with the bevel here. But if I was working with denser timber, say locust or cocobolo, some rosewoods, I might go more obtuse there because the the more acute angle will always be more aggressive and it will have a tendency to break off with denser timber. So there's a happy medium there, and 45 degrees is pretty good. Also, something to think about, I like my cutting edges either straight or convexed, but never concaved. Now, this is the exact same grind that we just saw, but I've had, so here's our 45-degree bevel there, and then I've removed the back of the bevel to make the bevel shorter. And the reason we do this is to do interior cuts. So when you do interior curves, you'd like a shorter bevel here so the tool doesn't leave a burnishing mark. So it's obvious if it was longer here, it's harder to get into a tighter curve. Now, also, I would use this tool when I'm trying to make really thin objects because the less surface area there on the wood will mean less tension. This is the traditional grind, also known as a bottom feeder. So I think this is a very important tool for wood turners for doing the bottom third of a bowl. And then always when you have grain that's hard to cut, this particular design seems to always cut wood cleaner. So there's no fingernail here at all. The gouge is cut straight across, and the bevel again is still at 45 degrees. And the reason we would adjust the bevel here would be if, let's go ahead to go to a whiteboard here real quickly. So if I had a bowl that's really tall, let's just make two bowls. There's bowl one and bowl number two. And if I have a 45-degree bevel on my tool, there's a possibility as I'm running it down the wall here and I'm trying to get all the way to the middle at the bottom there, that the angle is too acute, and it was certainly cut in bowl number one, but bowl number two, it would hit the rim. And that's why we would adjust the bevel to actually make that cut without running into the wall. And if you think about what the bottom feeder or the traditional grind is, you're looking at a spindle gouge that has a traditional grind on it. And again, this is made for spindles and not bowls because of the tang area here would not be good for bowls. It's easy to break. It's really weak there. And another thought about the design of the spindle roughing gouge and the bottom feeder. Let me share my screen here and we'll go to the whiteboard. When you have a spindle between centers, of course, the grain is running in this direction here. Your centers are here, and the spindle roughing gouge moves back and forth along this plane. It handles that end grain fiber really well. If you think about it, let's clear that off. It's the same thought as why it works in a bowl. So here's your bowl. And now your grain is running in this direction. And so when you use this tool in the bottom third of your bowl, you're working into the end grain fiber, and that's why it lays it down so nicely. Now, how do I get the angle set for my gouges? And this is my standard grinder here, and then it has a platform where the tool lays, and it reads out here at about 42 degrees, and I can make adjustments to get the angle that I want, or I can just guess and then use a tool to actually see where that bevel lies, and that's one of them right there. That's a 40-degree bevel there, and these little angles here show you what your bevel can be. So let's go ahead and sharpen a tool. And this one doesn't have a handle on it, which it makes it a lot easier to sharpen with at least the method that I'm showing you here. And what you're going to see is me clamp that tool down on that platform and never let it rock. It's always going to be at that angle, that 45 degrees in this scenario angle. And then I'm just going to grind all the way around the tool, keeping the tool flat on the platform. I'm a little bit in your way here, but I'll show you some close-ups. A little blurry there. Sorry about that. But notice the tool is always on the platform. Now, in this scenario here, I have the tool with a handle on it, but notice where my left hand is. I'm not down at the bottom. I'm up here by the ferrule, so I don't have the tendency to rock the tool off the platform. Now, notice my body is away from the grinders, so I can get the tool around without hitting my gut. It's got to be swung in a pendulum. More of the same. And I'm going to show you a close-up here. And hopefully I can get this point across. Let's stop right there. Now, I just mentioned right at the start about the bevel angle. And you notice I have a lot of tool steel here on the side of my tool. Now, the way I get that, so I'm thinking that angle is somewhere in the 45-degree area too. I never measure it, but I know it's close. And like I said, I think it's important to do that because as I cut, if the side of the tool has the same angle as the front of the nose of the tool, the tool feeds in evenly. It doesn't get caught. It doesn't. It's not aggressive. Something to think about. Very important. Now, in order to keep that angle, what I want you to notice here is I hit underside. I hit this side down here first, and then I roll the tool into the cutting edge. And as soon as I see a hot red spark come down the flute, I know I'm on the cutting edge. Let's take a look at that, and I'll make sure we stop right there. Now, now I'm right on the cutting edge. You can see that hot red spark has come into the flute. Now let's watch, and now I'm going to do the whole half of that gouge. And drop it, drop the tool handle, and roll it. And now I've touched the whole edge all the way around. Hot red spark. That's pretty much the method as to how I grind the tool. Now let's design a fingernail gouge. In my day, the tools never came with a fingernail gouge. They came with the bottom feeder or the traditional grind, and then you had to make the tool yourself. And that probably wasn't a bad thing because that got me into the concept of tool design anyway, and that's why I'm here talking about it. So here is the traditional grind here. And I'm already set with a 45-degree angle on my platform, so I could just kind of roll it on the platform here. And then I'm going to turn the tool over here, and you'll see I went all the way around. It's flattened off. Now, you basically, that reflective material, everything there that's reflective, I'm going to remove. And once I do, it's a sharp tool. You can see the outline of the flute. That's basically what you're going to want. And then you decide now if you want a flat or straight cutting edge or a convex. Convex is going to take a little more time to do. But let's go ahead and remove that reflective material, and we'll have a sharp gouge. Again, keeping my tool always on the platform. It doesn't get rocked up or down. And I'm moving over to this side so it doesn't get hot, too hot on one side. Now notice that hot red spark coming through the flute tells me I'm on the cutting edge. Now, that's a freshly sharpened tool. Now, I'm going to stop right there, and the next thing that you're going to see is me removing the sharp nose of the gouge. I've determined just by looks that there's too sharp of an angle or too sharp of a point on the front of the tool. And now let's just soften that. And I'll do that just by rocking the nose, just like that. And that softens it. Easy enough. That works good for me. Now let's shorten the bevel of the gouge to do interior cuts. And that's real simple too, if you think about it. Just pick the tool up and remove the back end of the bevel. There you go. And you can make that bevel 1/8 of an inch. If you look at some really good wood turners, they might even have a millimeter there. Just remember, the shorter the bevel, the better the wood turner. There's that tool again. Now, I'm going to show you some common pour grinds that I see when I travel. At first glance, you think, well, what's so wrong with that tool? Well, what I see wrong is, again, there's no tool still here on the sides, and there's really no pinnacle on the tool. It's kind of flat across. So when you hit the wood, it skates. It goes left, right, until you get bevel contact. It would be better if you've got more of a point on the tool. not a point, but just compared to what's there, it's more pointed. Okay, let's take a look at some others. Now, that is just what we just saw, too much attention on the nose of the gouge, and it's made a dip, oops, excuse me, and it's made a dip, too much attention on the nose of the gouge, and it's made a dip. It removed the top of the gouge, and that's not a good thing. You don't want to replicate that. It happens. Now, this is called the bird's beak. I see this one all the time. And again, it's the bevel has been too much attention right there with the grinder, and that's what caused it. And this is probably the most common pour grind, and it really doesn't look that bad, but it is. Um, this is going to take us into some other thoughts. So basically, the bevel angle here is too obtuse. You need more of an angle here to pierce into the wood grain. And let's go to the subject of sharpness of tools. Well, if if you thought about it, the type of material is important. So some woods are more abrasive than others, obviously, denser. Density sometimes doesn't mean abrasiveness, but and then the type of steel our gouges are made from. That's important. Most modern gouges are going to be fairly good tool steels, and they're all over the board. All tool manufacturers are using different types of tool steels, and the way they heat treat them, everything applies. With all those factors, the tool steel, the type of material we're cutting, nothing is going to change this concept. Let's go to a whiteboard here. Now, I if I let's just say I hear this all the time. Wood turners go, I use a CBN wheel that has 240 grits. Well, no doubt that when you take your gouge off of that 240 grit stone, it's going to be super sharp. But again, the more material that's going to go through that super sharp edge, the faster it's going to break down. So here's the concept. It's real simple. We've got a sharp point, and then we have one that's not so sharp. So if you sharpen the 240 grit, or 120 for that matter, the sharpener that it is here, it's going to dull off faster. But if I only got my tool this sharp here, it will last longer. And sometimes that's important. And I think in most times that's important because 95% of the cuts I'm making don't require super sharpness. So that's the concept here. Let's go. Let me draw a graph here as well. So if 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 that point right there is the pinnacle of sharpness, it's razor sharp. And then this line here represents maybe the sharpness that I get on my bowl gouges from an 80 grit wheel. And then let's just say that line there is dull. When you attack the wood, this is the graph, that line goes down quickly. Now, if you use an 80 grit wheel like I do, that line will go down, that line will go down slower. So that's the concept. How sharp do you want your tools? Well, again, as a bowl maker, not so sharp. 80 grit is going to be fine for me. And then if you were a small diameter wood turner, let's say you were making spindles, small diameter spindles, bottle stoppers, pens, that would be an argument for a much sharper tool because there's less wood going through your tool. And again, if you think about this, why do wood carvers use a lap to polish their tools, and they can literally cut the hair off their arm, they're so sharp? Well, those type of craftspeople need that sharpness of tool because they're chiseling away wood, and that carver will never see the amount of wood that a wood gouge we'll see in just a very short time. So it's about the how much material is going through the tool and for how long. Something to think about. Next, we're going to design a traditional grind. So if you have a fingernail grind and you want a traditional grind on your tool, this is how we're going to do it. $1, $2, $3. This is the easiest tool to sharpen because you lay it flat on the platform and just roll it around until you've got all that reflective material on. There you go. Now, if you had to adjust the bevel angle of your bottom feeder here, what I would do is to stick a finger in between me and the platform. And that probably changes the angle by 10 degrees, and that will get you into a taller bowl. Here's a close-up of what I just did. Well, that's pretty much all I wanted to say. Thanks for watching, and we'll do this again.